Welcome back. Today we're diving straight into one of the most exciting crossovers happening right now between robotics, AI, and next-gen gadgets. In one sweep, we've got Unitree's brand new humanoid robot, the H2, a full-size bionic machine that's starting to blur the line between industrial hardware and lifelike movement. Caltech and Abu Dhabi's Technology Innovation Institute unveiling X1, a hybrid system that literally combines a humanoid robot with a shape-shifting drone. And finally, a surprise entry from the smartphone world, Honor's Wild Robot Phone, which packs a fold-out AI-driven gimbal camera that behaves like a miniature robot on your desk. 3 different stories, one common thread: the fusion of intelligence, motion, and design. Each shows how robotics is leaving the lab and heading into everyday life, whether that's in a shopping mall, a disaster zone, or the palm of your hand. Let's start with the star of the week, Unitree's H2 humanoid. On October 20th, Unitree dropped a video that instantly trended across robotics circles. A 180-centimeter-tall, 70-kilogram humanoid robot moving with precision and agility that looked less like a demo and more like a choreographed human performance. It dances, balances, throws punches, and recovers from impacts, all with a smoothness that signals just how far gate control and torque management have come since the early Atlas and Asimo days. The H2 represents a major evolution from Unitree's earlier H1 model. The new version features 31 degrees of freedom. That's a 63% increase, giving it finer control and more natural range of motion across limbs and joints. Powering those joints are Unitree's custom M107 low-inertia motors, delivering around 360 Newton-meters of torque each. In human terms, that means H2 can lift roughly 15 kilograms overhead and perform deep squats without losing balance, an impressive metric for any bipedal robot at this size. Battery life comes from an 864 watt-hour swappable pack mounted in its lower back, enough for around 2 hours of active operation depending on load and speed. Its sensors include Intel's RealSense D435i depth camera and a LiveOx Mid360 LiDAR unit, giving it precise obstacle detection down to about 10 centimeters. On the compute side, Unitree is reportedly running an Intel Core i7 class processor with an onboard GPU module to handle visual SLAM, balance correction, and reinforcement learning feedback loops in real time. What that translates to is better recovery. When the H2 gets pushed, tripped, or jolted, it doesn't just fall. It learns from the imbalance and recalculates to stay upright. Visually, Unitree also took a big turn with design. Gone is the sterile, metallic, industrial bot aesthetic of the H1. The H2's body features smoother lines, dressed-up clothing, and a minimal bionic face that softens its presence. It's clearly an attempt to make humanoids feel friendly and acceptable in public spaces, a crucial step if the company wants these robots working alongside people in stores, malls, or offices. Here's where Unitree is really shaking things up: pricing and scaling. Earlier this year, the company stunned the market by releasing the smaller R1 robot at just 39,900 yuan. Roughly $5,600, a fraction of what most humanoids cost. Now the H2 isn't that cheap, but even its projected range, estimated between $80,000 and $130,000, is way below what Western rivals like Figure or Tesla's Optimus are expected to cost once they reach production scale. Founder Wang Xingxing has openly described Unitree's approach as full-size, full-scenario, full-price range. In other words, build a whole family of humanoids across tiers, from affordable developer and consumer versions under $20,000 to mid-range models for entertainment and retail, and full-size premium units like the H2 for industrial and service roles. The playbook looks a lot like consumer electronics: shared components, modular design, and mass production to push down cost per unit. Analysts estimate hardware gross margins in the 35 to 45% range. But if Unitree layers on software subscriptions, maintenance plans, cloud-based AI updates, and data services, total gross margins could rise above 60%. It's a model designed not just to sell robots, but to sell ecosystems. The goal is to seed affordable units into universities, startups, and developer communities, then scale upward into commercial deployments once the ecosystem matures. In short, Unitree wants humanoids to follow the same economic curve as drones and electric scooters, from luxury prototypes to mainstream hardware within a few product cycles. That said, there are some real risks. Security researchers recently highlighted vulnerabilities in Unitree's wireless provisioning system, including Bluetooth and Wi-Fi exploits that could, in theory, allow attackers to take root access or even spread malware between robots on the same network. For machines designed to operate in public areas, that's a serious liability. Fixing the issue is straightforward: signed firmware, hardened provisioning, and stricter network policies. But the deeper concern is cultural. Will Unitree treat cybersecurity as a top-level priority before regulators or customers force them to? Then there's manufacturing. Agility Robotics and other competitors have announced dedicated humanoid factories capable of producing thousands of units per year. Unitree hasn't publicly confirmed similar capacity yet, and scaling beyond research-grade production is one of the hardest parts of this business. The next big milestone will be endurance and reliability, proving these robots can run for weeks or months without maintenance, not just perform in polished demo videos. Now let's pivot to one of the most fascinating collaborations this year. Caltech and Abu Dhabi's Technology Innovation Institute, along with Northeastern University, unveiling X1, a multimodal robot system that combines a humanoid with a transformable drone. Here's how it works. The humanoid, a modified Unitree G1, carries a compact drone called M4 on its back. When the humanoid reaches a vantage point, it bends forward, launches M4, and the drone takes off. M4 can then land, fold its rotors, and switch to driving mode for ground travel. It even handles hybrid environments. In the demo, M4 rolled across Caltech's campus, reached the turtle pond, switched back to flight, crossed the water, and completed a delivery task before returning to the humanoid. It's a glimpse into true multi-robot cooperation, one machine extending the sensory range and capabilities of another. Caltech's contribution focuses on control theory and locomotion modeling, making sure motion is derived from physical dynamics, not just pre-recorded motion capture. TII supplied the Saluki flight controller and secure onboard compute, while Northeastern designed the morphing mechanisms that let M4 change shape mid-mission. The purpose goes far beyond cool demos. It's about autonomy in complex, unpredictable environments like disaster response or search and rescue. With hybrid mobility, the system can walk, drive, or fly depending on terrain, and crucially, do it without human teleoperation. It's an engineering approach that prioritizes physics-based reasoning fused with machine learning, so the robot's movements emerge naturally from the environment, not from scripts. And then, out of nowhere, comes Honor with something straight out of science fiction, a robot phone concept. The teaser shows what looks like a normal smartphone until the back panel slides open and a small mechanical arm rises, housing the camera module. The arm can rotate, tilt, and stabilize like a 3-axis gimbal. In the promo, it tracks faces, follows subjects around, and even gestures in what the company calls emotional interaction. It's essentially a built-in robotic camera designed for stabilized video, astrophotography, and AI-assisted tracking, like having a mini DJI Osmo baked right into your phone. Honor's pitch goes beyond photography. They're calling it an emotional companion, with AI that reads context, tone, and gaze to behave like a tiny assistant. Hardware leaks suggest a Snapdragon 8 Elite-class processor handling the AI workload, possibly with an upgraded NPU for local inference. But the engineering challenges are steep. A motorized arm introduces durability issues, extra weight, and significant battery drain. Still, if Honor can make it reliable, it could change mobile imaging entirely. A camera that literally moves with purpose, rather than relying on digital stabilization. The company says more details will drop in 2026, possibly at Mobile World Congress, which suggests they're serious about at least prototyping the concept. So what ties all this together? It's convergence. The blending of mechanical design, artificial intelligence, and scalable manufacturing. Unitree is pushing humanoids toward affordability and human-friendly design. Caltech and TII are proving that autonomous systems can mix walking, flying, and driving in one architecture. And Honor is experimenting with embedding robotic motion into consumer gadgets. Across every project, the pattern is clear. Shared components, modular architecture, and physics-aware AI. It's not just about building smarter machines. It's about standardizing motion and perception across form factors so robots can scale like smartphones once did. Of course, the real test won't be YouTube demos. It'll be uptime, safety, and security. The unglamorous metrics that determine who survives the leap from lab to marketplace. Watch for which companies start publishing independent endurance data, firmware patch cycles, and third-party audits. That's when we'll know these machines are moving from experimental to operational. Until then, enjoy this moment. We're watching robotics evolve in real time, from humanoids and hybrid drones to a literal robot camera in your pocket. That's it for today's deep dive. I'm glad you made it to the end. Stay curious, stay skeptical, and I'll see you in the next one.